For page 87, we're going to be graphing the log functions. So if you want to title it there, you can. You don't have to because there's already a title here. So this looks very similar to our graphing exponential functions. It works similarly as any transformation type would. So your parent function I have here, I have circled it or boxed it off. That's going to be your log, whatever your base is of x. That's going to be your parent. So when you come down here to actually go to graph and you make your table, the parent function would be log base 4 of x. These guys still represent the same thing, so you go ahead and highlight those. So your vertical stretch or compression, your horizontal shift left or right, and then your vertical shift up or down. Now, a logarithmic function does have a vertical asymptote. We'll learn about that today in class. And so if you shift it left or right, then that vertical asymptote is also going to shift left or right. So depending on whether it shifts right or left will determine where that vertical asymptote goes. So in this particular function, we have x plus 2 is going to shift it left 2, which means then the vertical asymptote would be at x equals negative 2. And you can see that in the graph down here. Now, when you're picking your points, I typically ask for 5 points for your new transform graph. So when you're picking your 5 points, you want to make sure and pick points that are good for the base of 4. What I mean by that is if you pick something like, for example, the number 2, no, 2 is actually okay, 3. For example, if you do log base 4 of 3, it's very hard to figure out what 4 to what power gives you 3. So when you come down here and you're picking numbers, notice they picked 1 and they picked 4. These are the types of numbers you want to pick, anything to deal with 4 to the first, 4 to the second, 4 to the third, 4 to the fifth, and so forth. Or 4 to the negative 1, 4 to the 0, 4 to the negative 2, and so forth. So you want to make sure and pick numbers that are good numbers based on the base. Picking numbers like 5, 6, 7, those would be a little bit tougher because 4 doesn't have an exponent that would go into those nicely. So same thing as before, since it's going left 2, we would take these x values on the parent function and subtract 2. And then the same thing with the y values, we're going to subtract 1 because it goes down 1. So from here you would plot those, and this would be your new graph. Your vertical asymptote would be here at x equals negative 2. You connect your dots, and then that'll be it. And that's it for this page.